Again, I'm Osterwood. I'm the CTO at Carnegie Robotics, and I'm going to talk about how we choose 3D sensors, how we evaluate them, and hopefully illuminate some of the edge cases and trade-offs between some popular 3D sensor modalities. Carnegie Robotics does two things. We build robotic components as well as custom systems. We're headquartered in Pittsburgh, and do this across a wide variety of industries. We're in the agriculture, military markets, industrial floor cleaning, and a whole host of other things. We're about 70 people, 7 years old, and we build our own stereo cameras and also integrate lots of other kinds of 3D sensors into the systems that we build, which is where a lot of the data and the results that are in this talk have come from through those integration efforts. So we're going to first start with criteria and definitions, give you some fundamentals on the verbiage that we use to talk about these sensors. And then we're going to do an overview of 3 different kinds of 3D sensor modalities, LiDAR systems, time-of-flight cameras, as well as active and passive stereo. And that'll include a very brief summary of how they work, what are their general advantages and disadvantages, as well as some sample data from a single environment to sort of show you qualitatively how these sensors behave and how they work. Then go into a little bit more detail on 3D sensor testing and some edge cases, and this is a little bit more quantitative with some results from laboratory testing that we've done, and finishing up with some final thoughts. I'm going to note that we're not covering many other kinds of 3D sensor technologies like computed tomography, structured light, and laser triangulation. Those are appropriate for many kinds of systems, but not for the mobile outdoor robots that we build. So we don't have the same kind of test data and insights into those modalities. So we're focusing today on LiDAR, time-of-flight cameras, and stereo.